All right, let's try another one of these modified period trig equations. In this problem, what we want to do is we want to find the first two positive solutions of the equation 7 sine of 5x equal to 6. Again, keep in mind, we're trying to get the x by itself. It's currently trapped inside the sine function, and so I'm going to have to undo the sine function in order to solve. However, the trig function part of it is not by itself yet, so I've got to get rid of anything else that's in the way. And in this case, that is the 7. So I'm going to start this problem by dividing both sides by 7, which is going to leave me with the sine of 5x is equal to 6/7. Now, 6/7 is not one of my standard values over here on my unit circle set. So at this point where now I'm ready to get rid of the sine function, so that I can work my way to getting the x alone. To get rid of the sine function, I can't just use my picture, so I'm going to have to use my calculator. So what I'd like to do is I am interested in find the values on the unit circle. I need to find the inverse sine of 6/7. So I'm going to go to my calculator to do that. Again, please make sure that your calculator is in radians mode. And then once you're there, we can go ahead and use the inverse trig function. In this case, we were dealing with sine, so the inverse sine of 6/7. And it's fine to go ahead and just leave the fraction in there as long as you're inside parentheses on your calculator. So if we hit enter here, we get 1.0297. So let's go ahead and write that down. 1.0297. And this is the value that we get out from taking the inverse sine. Keep in mind that when we took the inverse sine, what that left behind here was that 5x was equal to this value. Now, because of how the unit circle works, when we found our first value here, we just used the inverse trig sign, and we got this answer here. Now, 1.0297 is an angle here in the first quadrant because it's less than pi over 2. Also, we know that the sine function is positive in the first quadrant, and the sine is also positive in the second quadrant. So sine is positive in first and second quadrant. So because when we took the inverse sine function, it gave us the first quadrant values, that's one of our answers. Our next job is to figure out where this second quadrant answer is. So this one was the 1.0297. I need to figure out where this one is. Keep in mind when you're finding your other values on the unit circle, we're using that kind of butterfly symmetry from the x-axis. So here's my first quadrant answer, 1.0297 radians up. And then because I need my answer to be in the second quadrant, which is where the sine is positive, I'm going to need to go 1.0297 radians up from the x-axis here. So at this point, I'm starting at pi, but I need to go backwards 1.0297. I need something smaller than pi. So I'm going to do pi minus 1.0297 to get my second solution here. So let's do that on the calculator. So I need to find pi minus that last answer. So 1.0297, I'll go ahead and hit enter. And I get 2.1119. That's going to be the second answer there. So this is 2.1119, and it will be my second solution here. 2.1119. So again, let's kind of backtrack a little bit and see where we came from. We started with 7 sine 5x equals 6, got the trig function by itself by dividing by 7, and then in order to get my function out, to get this x out of the trig function, I used the inverse sine. That gave me a first quadrant answer, and then I had to use the fact that I knew the sine was positive in the first and second quadrant in order to figure out what the second quadrant solution was. Now, these were the values that came out from the unit circle. However, because what was inside the trig function was 5x, these values here from the unit circle are not my values for x. They are actually what 5x is equal to. So in order to find x, what I'm going to have to do is I'm going to have to divide by 5 on each side to get my two solutions. So for my first solution, I'm going to take 1.0297 and divide it by 5. 1.0297 and divide it by 5. And we get 0.20, we'll call it 0.206 radians. So this is my first positive solution that I get correlating with that first quadrant as I'm going through my my unit circle spin a little bit accelerated here. So this gives me my first value of x. My next equation here said that 5x is equal to 2.1119. And so in order to get x by itself, I'm going to divide both sides by 5. So let's go do that. 2.1119 divided by 5 gives me 0.422. I guess we'll be consistent there. So x equals 0.422. So what I have here is my first quadrant correlating solution as I go around the unit circle. Here I have my second quadrant solution as I'm going through the unit circle, since those are where the sign is positive. Now, go back to the problem to decide. In this case, the question was just asking us to find the first two positive solutions. So we're just looking for the two places within the unit circle where we end up with this equation being true, and this is what our values are, and that's the answer that they're looking for. Keep in mind, if they wanted any more solutions, then we would have to do is we'd have to add multiples of the period. In this particular problem, notice that we do have a modified period, and we can use the fact that my new period is going to be 2 pi divided by b, which in this case was 5. And so if I needed more answers, what I could do is I could add multiples of 2 pi over 5, or 2/5 pi, and I'd want multiples of that, so 2/5 pi k. However, because all it wanted was the first two positive solutions, it's these two, and then any other answers would be multiples of those. So this here would be your final solution. But we could get any other answers that we wanted to by doing that plus 2 pi over 5k, since that's our modified period.